Okay, so welcome back. For chapter 12 about stack. And in this lecture, we are going to go over about capacity bounded stack implementation using an array. Okay. And the example is Java stack example 1 stack int. So this stack int is our class, okay? And because we are going to implement the clone method, so we also implement the clonable interface. And the array, so here is the array, okay, for the instance variable. And this is for the index, okay. And this is the constant, so it's a static final, and the capacity is 8. For the default constructor of the stack, so we just create an empty one, an empty stack. Okay, what it does is it's on heap, it allocates memory for this instance variable ARR. Okay. It also initiates a top index to -1. Okay, so why we do this? So before we move on, let's take a look about using array to implement the stack concept. Okay, suppose we have this sequence of number. Okay, 29, 51, 308, 65, 55, and 78, 81, 99. Okay, we have 8 numbers and we want to store them in a stack. So how do we do that? Is it so the idea is we implement using array. Is it so then array has index. So we basically kind of like you can think it has 8 slots, is it? And each one is also index. So the bottom one index 0, 1, 2, and all the way to 7 is a total 8. Okay. And this is 6. Okay, index. And so the first number we want to add is 29. Is it? So 29, we're going to push it. Is it? So 29. Okay. So basically here 29 is stored at the sub-zero. This is basically ARR sub-zero is going to be assigned with 29. Okay, but how do we keep track of the top? Is it so then at this point top is 0? Is it? But then the question is, how do you know if the stack is empty? So that's why we initiate to the top to -1. Okay, so top equals -1 when empty. Okay, then let's see. Next, we want to add 51. So we do another push. So 51, is it? So then top change it to 1, is it? And the ARR sub 1 is going to be 51. And then you're going to add 308, push it, is it? So then ARR2 is going to be 308 and top is 2. Yeah, you can see each time if we do the push operation, what it happens is the top index is incremented by 1. Is it? It's incremented by 1 each time, okay? And until like 99 is added, okay? So then it's going to be ARR sub 7 is 99. and top is 7. And at this point, the stack is full. That's it. So basically, with this array implementation, we can also check, okay, stack empty, then top is -1. And if you want to know if the stack is full, you can use the top. So basically, top should be the capacity -1, then that's full. The stack is full. Okay. So what is the push operation? Then we can see it's basically is top plus plus if it is not full, is it? And then the respective array item is going to be assigned with the item. Okay. So that's what the push does. Okay. And then for the pop is you try to remove, is it? But you think in array, basically we cannot remove, is it in Java? Okay, it will be stored. So how do we indicate that basically the 99 is already removed? So the top index. So now top is at 7, is it? So if we remove, but 99 is still here, okay, still in a heap, okay. It's still in array. What you can change is you decrement by 1, then top change it to 6. That's it. And each time, so basically we remove, if we implement using array, we are not actually remove item from the array because we cannot. It's just we use the top index to indicate, okay, where the top item is. So then it's going to be -1 again, is it? Until when you reached like -1, then you already know that the stack is empty, so you cannot do any remove operation, okay, pop operation. Okay, so in what we just illustrated, we can see for the push operation, the major important thing is you increment the top. That's it. And at the same time, you also assign the item to the array. And for pop, you decrement. So decrement the top index by 1. And we don't need to do anything for array. Okay, so nothing needed to do for array. So now we understand how we use array to implement the stack data structure. Okay. And then next, let's take a look about the example, how we implement it. So the concept we understand now. Okay, and the constructor, the default constructor, we also understand. Now let's take a look. The second constructor is a constructor with parameters, with argument. So the explicit, we also call it explicit value constructor. So what it does, so the parameter is an array, okay? So what you want to do is you want to initiate the stack with this array. So here you have this input array. Input array. So you want to get the item from the array to the stack. Okay, that's what we want to do. So how we do it is we can call arrays copy of range function. Okay, and then you specify where you start and the capacity is it, and then it will copy of the item to the array. And also at the same time, we also need to know where the top index is, okay? And when we do the array copy and we needed to know which one is the minimum, if the capacity minus one is minimum or the array's length minus one is the minimum. We take the smaller one, okay? And if the input array's length is greater than the capacity, then we cannot copy off that, is it? So we just copy part of it, okay, to the stack. So that's the uh, constructor with arguments. And then for the empty method, you just check if the top index is -1. And for the push operation, we already discussed, is it? And of course, if it's already reached the capacity, then we can throw some exception, okay? So runtime exception, so unchecked, this is illegal state exception. And so for the push, it's you first increment the top index by 1, then you assign the item to that array element. So that's what push does. And for the pop, okay, so if it is empty, then you throw the runtime exception. Otherwise, for this pop operation, to also return the top item, so whatever it removed, okay, so you can use a temp a local variable to remember it, and then decrement index and return that item. So pretty straightforward. And for the pick operation is to retrieve the top item. Okay. So if it's empty thing, we need to throw exception. Okay. Otherwise, you just return the top item. And then the implementation for the toString. Okay, so we are going to use a string builder to keep all of the items. Okay, and we for each of the item we separated using the semicolon. Okay, so because it's an array, so we can directly using arrays index to access the item. Okay, and this is just to delete the last semicolon. Okay. And we include everything in the square brackets and convert it to string. Okay, so also pretty straightforward for the toString implementation. And lastly is a clone method. We overload it, okay. And because for the clone, it's a return another stack object. So we needed to create a new stack object. And we just copy the index. And also this is a real deep copy, okay? So for the array, we use a deep copy of the instance variable. Then you return the stack object. Okay. So that's a deep copy of the stack. So this is for the stack class, and here we have the driver to test our stack. So we first create our stack object, okay? Then you can check if it's empty, you can call toString, and then you add 29, is it? Then you can check empty, retrieve, and toString again. And then we add the sequence of item. Okay, and then you can get the top item and output the complete stack. And here what we did is we create a deep copy of the previous stack and then remove the top two items. And here is an array, okay? And this time we create a new stack object using this array, okay? And here we have another array. This array is the same size as target array, okay? So what we do is over here, we use stack to reverse array. Okay, so stack is very good because last in, first out, is it? So last in, first out feature is very good for reverse something, okay, reverse linear, okay. So what it does is you can see that then you just keep a pop of the stack and add the item to the new reversed array. Okay, then we can check if both if the array is reversed or not. Is it? And here, if you take a closer look, you will find the array is symmetric. If the array is symmetric, then the reversed one should be the original one, have the same context. Is it? So that's why we can use arrays structure equality to check, okay, if the original and the reversed one are the same. Okay, so basically we also do the palindrome check. Okay, so that's the implementation of the first example, and the running result we can see, yeah, it does reflect of us the information. And because this array is capacity bounded, and if you recall previously, the stack is already full. So if we try to add a new item, so I commented out that push 100, okay, then let's see if we can still make it. And you can see, yeah, it complains. Is it? It cannot add, so it's said, yeah. So the exception happens. The stack is already full. That output that. Okay, so that's the discussion for the implementation of stack, capacity bounded stack using array. Okay. Okay, so we are going to discuss the unbounded one in our next lecture. See you.